Welcome back, students. We're in lesson 10. We're going to talk about the Pythagorean theorem. The Pythagorean theorem, we know, is all about the hypotenuse of a right triangle. And let me refresh your memory. Pythagorean's theorem is a squared plus b squared equals c squared, and all that means is that if you have a right triangle as such, well, hopefully I could draw it better. Let's do this. Now we have a right triangle. All right, if you have a right triangle as such here, let me get my pen back. We know it's a right triangle because we have that little square down in the bottom. Then this could be side A or this could be A. It doesn't matter. We could take this measurement and figure out what this measurement is. Or we could take this measurement and this measurement to figure out what this measurement is. But as long as we have two of these measurements, we could figure out what the third is. And he is just saying Pythagoras, figured out in ancient Greek days, a long, long time ago, that there's a relationship between the length of this side and the length of these two sides. And that relationship is this here. That if you square this one and you square this one, then the square of this one, it always equals the square of this one. So if you can get two of these, you could figure out the third one based on that relationship. So we're going to talk about that in example 10.1. So here we go. We have a right triangle, and I'm going to try to draw one for us now, again, in the dimensions that it's given. Oh, not too shabby. Okay, so we have, this is 8, this is 7, just, hold on, sorry. Wrong one. This is 4. And this is 7. So we're going to, I'm sorry, that's not 8. That's A. I need to get my glasses cleaned. All right, we're going to use Pythagorean's theorem. I don't know why I can't say that today. To try to figure out what A is. So we know that these are A's and B's. The two legs that are creating the 90-degree angle are considered A and B, and it doesn't matter which one is which because they're added together. The commutative property of addition tells us it doesn't matter. So we're going to say that this is A is A squared plus 4 squared, and it should equal 7 squared, right? So let's do the math as we know it. So A squared, we can't do anything with that. 4 squared is 16. 7 squared is 49. Now we're going to solve. Change signs when we change sides, or vice versa. So that's going to be A squared equals 49 minus 16. And that's going to be 33. So A squared equals 33, which means that A is equal to the square root of 33. Solved. You don't always have to get a whole number to get the right answer. This is what A is. It is the square root of 33. And the reason we went from here to here is because those are reciprocals of one another. So what we technically did, and I just didn't picture it, is we said the square root of A squared equals the square root of 33 to get rid of the square. And A squared is A times A, so we can pull that out. It's A times A, so that's our pair. So we can pull it out of the radical as A. A equals the square root of 33. That's as far as we could take that because our factors of 33 are 3 times 11. So we don't have a pair we could easily pull out. We'd have to do the math and we'd end up on the calculator. We'd end up with this really long decimal number that would be kind of weird. So we just leave it like this. This is more succinct. And it's entirely accurate. Just because it has a radical doesn't mean it's not accurate. All right, so we have one more, and that is it. We're going to do 10.2, and we're going to use some graph paper this time. Okay, so we're going to use a Pythagorean's theorem to find the distance between the points and the points. This is 10.2. The points are 4, 2, and -3, 4. All right, so we are going to use Pythagorean's theorem in order to do that. And remember, it's a squared plus b squared equals c squared. So let's draw our graph. All right, that should be good. And that should be good. All right, so now we need to plot our points. And so we need 1, 2, 3, 4 on x and 1, 2 on y. There we go, that's 4 and 2. And now we need -3 on x. So 1, 2, 3, and +4 on y. 1, 2, 3, there's 4. All right, so now we're going to draw our line. Let's see if I can get it to go right through. All right, here and here. All right, that looks pretty good to me. So let's see what our slope is. We have, goes to here and it goes over to here. All right, so we have a slope of 2 here. That's on the y. And then we have 1, 2, 3, 4, 5, 6, 7 over here. So we have a slope of 2/7. Let's write that here. So here's our slope, 2/7. So what that means, in order to find the distance between these two, we have to use 2 and 7 in Pythagorean's theorem in order to find the distance here. So we're going to put the 2 in here and the 7 in here, and we're going to find out what c squared is. C is the hypotenuse. This is the 90-degree angle. That's why we chose the ones we chose. So that's 4 plus 49 equals c squared. 49, that's 53 equals c squared, right? So we are going to, again, unsquare everything, which means c times c is c squared. So the square root of 53 equals c. We can't unsquare that. So the distance from here to here is the square root of 53, and that's our answer. Easy peasy. All right, that's all we have for lesson 10. I'll see you in lesson 11.